Hi everyone, this is the lecture of the first week of Machine Vision class. We will study overview of the Machine Vision today. This lecture starts with the overview of Machine Vision, and then we will learn about the pattern recognition, which belongs to the high-level vision area, and then image processing, which belongs to the low-level vision area, and finally the digital image will be explained. This is the overview of machine vision. Machine vision is a kind of a computer vision, but machine vision is more oriented to the industrial applications. Four major application areas are measurement, location, counting, and decoding. Machine vision system is the eyes of the machine, such as on inspection machines or on industrial robot. Machine vision is widely used to automatize the inspection system, which replace many workers. You need to visit 3 YouTube videos by clicking the links I put on the slide. This shows the application area of the machine vision system. Unlikely with the general computer vision, the machine vision system is running in a controlled environment that includes light, camera, and chamber. This system is sorting mango fruit based on the color of the mango. Mangoes on the conveyor belt are transferred to the image capturing chamber. There are a CCD camera and a lamp whose light is controlled by the light intensity controller. CCD camera classifies the mangoes into 4 groups based on the color of the mango. The image of the mango is sent to the computer and analyzed by object recognition or object classification software. Finally, one of the 4 groups is assigned and signal to the switch controller to open the corresponding switch. Then mango is sorted. This slide shows another example. This system inspects the product and sort them into 2 groups, good product and bad product. They use 2 cameras to inspect the product. There are many different methods in inspection system based on what kind of faults they want to find. If there is a bad product, the alarm will be on. Please examine this vision system and please try to understand what's going on in this system. This diagram shows the hardware and the software of the machine vision system. There is a lighting system and sometimes a laser system to capture the 3D information. Lighting system is very important to eliminate the unnecessary shadows or highlights. Digital image are captured by the frame grabber about 15 years ago. Frame grabber was a PCB card type hardware installed inside of the PC. But nowadays, the computer can capture the image without the frame grabber. Image processing step can enhance the quality of digital image by eliminating noise and balancing the contrast, etc. Then segmentation and the feature extraction are performed. Segmentation is a process that distinguishes the object from the background. Features are some characteristics that can uniquely define the object that will be used in the object classification. For mango example, the color was a feature. Image processing and feature extractions are called as a low-level vision that usually manipulate pixels. In high-level vision, object recognition or pattern classifications are involved. Here the pattern and the features are the same, the meaning. Then application program execute some useful actions based on the decision from the object recognition program. Usually, commands are sent to the motor controller or robot controller. Okay, those are the overview of the machine vision system. Please remember the whole system layout of the machine vision system, and when you study some machine vision technique, the difference between the computer graphics, this technique belongs and image to processing the specific steps and computer vision of the whole machine vision system. If you know the description of the object, then you can create realistic image of the object using computer graphics or a 3D CAD system. If you have a digital image captured from the camera or created from the computer graphics, it might be a noise or low quality image. Image processing is a process that enhances the quality of the image. The low quality image will be transformed into the high quality image by applying the image processing. Okay. You can see the difference between the two images. The right image is much better than the left image. Computer vision is the process that extracts the description of object from digital image that consists of numbers. There is a car plate numbers, and the computer vision system can recognize what is the meaning of that. Object recognition is the same word of a pattern recognition or the feature classification, because the object is described by the features which have a form of a pattern. Here is a banana. How can you recognize that the object is a banana? You may say it has a yellow color and a long and curved contour. You should extract the yellow feature or pattern from the color information, and you need to express the long and curved contour with equations or numbers. Here are characters. There are many characters with different shapes, and how can you recognize the character from this image in handwriting, you need to extract the feature that describes R. Then you can classify that pattern into one of the 26 alphabet groups. That is a pattern recognition or feature classification or object recognition process. This slide shows the pattern recognition process. The image processing is applied to the dark input image whose balance is not good. Then the quality of the image is enhanced. Then the banana should be segmented from the background. That means which area is a banana and which areas are background. We should differentiate these two objects. By image segmentation process, the contour of the banana is extracted and superimposed on the original image. Then features that represent the shape and color of the banana are extracted. Then banana is recognized by the pattern classification. So it is very important to extract feature. So you need to decide what kind of feature you will use, and you need to develop the object recognition software. Then if you have a feature and you already have many library of the object, for example apple, the watermelon, and some patterns, you need to already have that kind of pattern. Then you need to decide this current extracted feature belong to which group. So it is a pattern classification process. Then the best match will be the answer of the pattern classification. This slide shows a pattern classification process. In banana classification problem, it uses two features. One is color and the other is thinness ratio. This is a description of a thinness ratio feature. T equal 4 pi A divided by P square. A means area of that object, and the P is a peripheral, so the contour length of contour of that object. So in case of the circle, so area is pi r square, and the peripheral is 2 pi r, and take the total square. That means it is 1. That means 1 is a totally round object, and as the number is decreased, the shape become longer and longer. And this is a thinness ratio. The color become red and yellow. So there are two groups. By analyzing the input image, we can find out two groups of the object. So this area represents that it has a red color and a round shape, and this group represents the yellow color and the long shape. So banana belong to here, and apple belong to here. But so by finding out this straight line, we can classify the pattern here apple and here banana. But there is some opaque area, so it hard to distinguish object. There are sometimes hard to distinguish object near here. So in order to classify that kind of object exactly, we can apply the artificial intelligence technique and the big data deep learning technique. So that is the basics of pattern classification. In order to get the better result from the object recognition process, the input image should have high quality. So in order to get the high quality image from the original image taken from the CCD camera, we should apply the image processing to the original image. There are four fields of image processing. One is image enhancement. The second one is image segment. Third is image transform. Fourth is image compression. This slide shows the first application area of image processing. It is image enhancement. Image enhancement is used to improve the image visually by using knowledge of the human visual system's response. That means we first study how human can enhance the image in our eye system, visual system. Then we apply that technique to the computer vision program. So there are two images left on the left side. This image have a low contrast. It is a bad image, and by applying the image enhancement, we can adjust the contrast. Then we can get the very nice image on the right side, and lower left is ill-focused image. Then we can enhance the focus using by applying the image enhancement technique. Image segmentation is the second application area of the image processing. Image segmentation is used to find the region that represent the object or meaningful parts of the object. So here is an original image of a flamingo, and human can differentiate which pixel belong to the flamingo and which pixel belong to the water. But in computer cannot know the differences between these two objects. So digital image has only number. So based on the information on the number, we can segment that the area into small pieces based on the similarity between neighborhood of the area. So you can see the many segments in the flamingo's body, and then these segments will be merged based on some rules. Then finally we can find the one big flamingo segment. Then computer can tell this is a flamingo, and this area belong to the water background. That is segmentation. So after finishing the segmentation, then we can extract feature from the segmented image of the object then that feature will be used in the object recognition. The third application of image processing is image transformation. The original image is transformed from the image space to the frequency space using FFT. FFT means the fast Fourier transform. And when we apply the low pass filter to the image in the frequency space, here is a low pass filter. When we apply the low pass filter, we can get this result. Then after applying the low pass filter, then by applying inverse FFT, we can get this result. Since only low pass frequency passed from here to here, high frequency component that describe the edge of the object is eliminated. So we will get the blurred image. So when we apply the high pass filter to this image in the frequency space, then we can eliminate the high frequency area. So then when we apply the inverse FFT to this image, then we can get this result. You can see the edge is highlighted here. So edge, there are many high frequency components in edge image. So this FFT transformation is usually used to extract edge image. The first application of image processing is image compression. The image compression is used to reduce the massive amount of data needed to represent an image. So in order to save some storage or boost up the calculation speed, we need to maintain the size of the image is small. Okay, and the size of original image is this amount. There are 640 row, and this is a column, 640 column and 480 row. There are this amount of pixels, and there are 3 channels for color image, red, green, blue channel. Then the total size of the original image is 900 kilobytes. So by applying the image compression, it is compressed, and 22% of the original image size. It resulting the size of the image is 200 kilobyte. This image is 5% of the original image, and the size of this image is only 3% of original image. So this is the result of the image compression. This image is image is original image, and this is a result of the image compression. So can you see the difference? So by applying the image compression, you can save a lot of memory without losing much information of the original image. This is the end of the first class, and next class we will start with the digital images. If you have a question, then please discuss and upload the question to the KakaoTalk room. Bye bye.